A very good morning to everyone and to our lecturer, BNJ Mohammad Asri bin Azizul. Okay, I'm the leader of Group 1 and our group title is Newton's second law, which is case A. Today we will present about our project. This is our group members, which is myself Madhivanan, and metric number is CN200084. Abdul Basit, metric number is CN200088. Kalishwar, metric number CN200224. Carmini, metric number CN20009, and finally Mohammad Afizuddin, metric number CN200030. The introduction. The aim of the experiment is to study about the Newton's second law. And in this experiment, there are three situations to investigate the acceleration of the object, which depends on two variables, which is net force acting on the object and the mass of the object. The force required to push or pull a toy car can to be determined in this experiment with the concept of Newton's second law. The next is literature review. The first one is Newton's second law. Newton's second law can be stated as F equal to mass times acceleration, which is mass equal to mass of the object, and the acceleration is the speed of the object. When a constant force acts on a massive body, it causes to accelerate. For the example, change in velocity at the constant rate. The unit of F equal to ma is Newton or kilogram meter per second. Okay, now we all can see a picture in our right side. Okay, in the picture there are a trolley and a man is pushing the trolley. When the man is apply force to the trolley with the particular mass, it starts to accelerate, which is speed increase. When more force the man is push the trolley, the more the acceleration, which is speed, is increased faster. The second one is weight. Weight can be concluded as W equal to mg, mass times acceleration due to the gravity, which is gravity equal to 9.81 meter second square. So the unit of weight is Newton or kilogram meter per second square. If more force act on a particular, it can be called as a resultant force, which is Fr. Fr equal to ma, as the same as the Newton's second law, and it's a vector summation of the all forces. Okay. After that, we need to draw free body diagram and kinetic diagram. Free body diagram is all the forces in the particular object. Then we draw the free body diagram with the forces. Kinetic diagram. Kinetic diagram is which we can know the internal force acting on the object. Okay, other than that, friction. Friction is between force. Friction is a force between two surfaces which are sliding or try to slide or across each other, such as a push or pull object in a floor on a surface. Its work in the direction opposite to the direction in which is moving objects. Friction and inclined plane. Okay, the friction in inclined plane, when the block is motionless on an inclined plane, that make an angle theta with the horizontal. Weight can be resolved in two components, which is parallel and perpendicular. In perpendicular, mass times gravity times cos theta. In parallel, mass times gravity times sin theta. When we assume the block is moved with a constant velocity and no acceleration, then the mg sin theta must be equal to the frictional force. Mg sin theta is equal to the static friction. Static friction is equal to coefficient of static mass times gravity times its cos theta. Mg sin theta is equal to coefficient of static theta, static friction, cos theta, and it's become finally coefficient of static friction equal to tangent theta. That we can find our coefficient of static friction by using this formula. Okay, this This is methodology. Okay, the material we use in our project is a box, an inclined plane with a smooth surface as a cardboard or a book, but we make sure the surface is smooth to minimize the friction between the troika tire and the surface. So the object we use in this project is troika, and we use manual weighing machine to calculate the mass of the troika. So in the inclined plane, we use protector to calculate the angle of this inclined plane. There are three situations in our project. Which is situation A, zero acceleration up the ramp. Situation 2, student B accelerating up the ramp. And situation 3, student C zero acceleration down the ramp. In these three situations, we record the time taken to the car reach the final point. And we use this time taken angle to calculate the force and the frictional force acting on the toy car. Thank you. That's it from me. My another group member will continue our presentation, our testing of our project. And now we want to calculate the weight of the toy car using manual weighing scale. So the mass of this toy car is 12.5 gram. And now we set up the inclined plane, and there is the projector, the toy car and box. So now we have took the measurement of this inclined plane using projector, tape meter to calculate the length of the inclined plane, height of the inclined plane, and this is the toy car. This is the free body diagram of the inclined plane. So now we go to the situation 1 is student A. Now is student B. The time taken is 0.2 second to the troika from bottom to the top of the inclined plane. And the final one is the student C. This is the inclined plane for the situation 3, and the angle of this inclined plane is 17 degree. And we use different troika at the situation 3, which is the weight of this troika is 0.04 kilogram. And now we conduct our situation, which is down accelerating down the ramp, and the time taken is 0.3 seconds.
A very good morning to our lecturer in Asri and my friends, and to my friends, sorry. So we are from Group One has conducted a project regarding Newton's second law, which includes three situations where student A is zero acceleration up the ramp, and student B is acceleration up the ramp, and student C is zero acceleration down the ramp. So for my part, I would like to discuss about the test and results. So let's go to the table. So for student A, the mass is 0.0125 kilogram, and the distance is 0.433 meter. The angle is 15, and the time taken is 0.2 seconds. And the total force required for student A is 0.317 Newton. So the second is student B. The mass for student B is 0.0125 kilogram, and the distance is 0.433 meter, and the angle is 15. The time taken is 0.2, and the total force required for student B is 0.0587 Newton. So from this, as we can see that the mass, distance, angle and time is same for student B and student A, but the total force required is not same. So for student C, the mass is 0.04 kilogram, and the distance is 0.433 meter, and the angle is 17, a bit higher compared to student A and student B. The time taken is 0 second. So the total force required for student C is negative 0.11473 Newton. So from this we can conclude that the total force required for student B is higher compared to student A and student B. So that's all from me. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afizuddin bin Muhammad Rozi, metric number CN2030. Today I would like to present about calculation of our project. In this calculation, we need to find the force of the object that move in three situations, where the first situation for student A, the object is 0 acceleration up the ramp. Then first we need to draw the free body diagram, FBD, and kinetic diagram. Then we get times equal to 0.2 second, and the angle of the inclined plane or ramp is 15 degree, and the mass of the object is 0.0125 kilogram. Then we need to find the weight of the object. We use formula W equal to mg, where m is presenting for mass and g is presenting for gravity of the earth, that is equal to 9.81. W equal to 0.0125 times 9.81, and then W is equal to 0.122625 Newton. Then to find the force of the object, the acceleration of the object is 0, because the situation is 0 acceleration up the ramp. Then we use formula F minus mg in bracket sine theta equal to 0. Then we move the negative mg in bracket sine theta to the right side. F equal to mg in bracket sine theta, and then we put in the value that we get. F equal to 0.122625 times sine 15 degree. Force is equal to 0.0317 Newton. Second situation is student B. The object is accelerating up the ramp. First, we need to draw free body diagram and kinetic diagram, and the times given is 0.2 second. The angle of the ramp is 15 degree, mass of object 0.0125 kilogram, and the distance of the ramp is 0.433 meter. Then we need to find the force of the object. We use formula F minus mg in bracket sine theta equal to 0. Then we put in the value that we get. F minus 0.0125 times 9.81 times sine 15 degree equal to 0.0125 A. A is acceleration that we did not find yet. So F is equal to 0.0317 plus 0.0125 A. And then to find the acceleration, we use a formula. Distance is equal to initial velocity times multiplied by times plus 1 over 2 multiplied by acceleration multiplied by times to the power of 2. And then we put in the value into the formula. 0.433 equal to 0 plus 1 over 2 a times 0.2 to the power of 2. Then 0.433 is equal to 0.2a. And then we divided 0.433 divided by 0.2, and last acceleration is equal to 2.1625 meter per second square. Then we substitute the second equation that we get into the first equation, and we put in the value. F is equal to 0.317 plus 0.0125 times 2.165. F is equal to 0.05876 Newton. And the last situation calculation, where students see the object 0 acceleration down the ramp. First, we need to draw free body diagram and kinetic diagram, and we get the time taken is 0.3 seconds. The angle of the ramp is 70 degree, and the mass of the object is 0.04. Then we need to find the weight of the object. W equal to mg. W equal to 0.04, that is mass of the object, and 9.81, that is gravity of the earth. And then we get the weight of the object is equal to 0.39124 Newton. After that, we need to find the force of the object. We use formula F plus mg in bracket sin theta equal to the max of the acceleration, that is 0. F, and then we put in the value that we get. F plus 0.3924 times sine 17 degree equal to 0, and then force F is equal to negative 0.11473 Newton. The negative sign of the answer is because it is decelerate down the plane.
Hi, my name is Karmini and my metric number is CN200009. So I will continue the observation of this project. The total force needed for the car to accelerate the inclined plane in the setup for student case A is 0.0317 Newton. A very minimal friction defected, but it had never affected the flow of the car as it has been accelerated quite smoothly along the inclined plane. This was because it has zero acceleration up the ramp. The total force detected for case student B, and the car is accelerated up to the inclined plane, which is 0.0587 Newton. This happened because the specific amount of acceleration was able to be found and it has traveled up the ramp. Lastly, for the case student C, the total force as the car has been run down the inclined plane with zero acceleration is 0.11473 Newton. It does have a little bit of negative sign in front of it to explain the car decelerates down the inclined plane. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. My name is Abdul Basit bin Mahmud. I will present about discussion our project. In this experiment, we have been given the task of Newton's second law About second law Newton's, the thing we need to know the formula of second law is F equal ma. The meaning of the formula is force equal to the mass time acceleration. But in the experiment, we use W equal mg. This formula is the same with F equal ma. On the Earth surface, g acceleration can be taken as g equal 9.81 meter per second square. From the experiment we do, we use a toy car to find the force in three situations. For student A and C, the acceleration is 0. Student need to find the force of the toy car in three situations. After that, we need to relate the measuring about weight of the car, angle of the ramp, time taken and the distance in Newton's second law formula. For student A and C, he need to calculate the force in zero acceleration up and down the ramp. Firstly, he need to calculate W equal to mg. W is weight of force equal to mass time g. G is acceleration. After that, calculate F equal to mg sin theta. Force equal mass time g time angle of the ramp. And then he get the force in that situation. But for student B, the force will be negative because the toy car in the situation move down. Different from student C, he needs to find the force and the acceleration up the ramp using the formula S equal to ut plus 1 over 2 at square. Distance equal initial velocity times time taken plus 1 over 2 times acceleration times time taken power of 2. He can get the motion or acceleration. Substitute the acceleration into the formula of force and he will get the value of force. Thank you.
Next, I will continue the presentation about conclusion of the project. In this experiment, it is to investigate the Newton's second law by determining the force required to push a mass of wheel that is a toy car up or down an inclined plane. The toy car is to be pushed in three different situations, where first situation is 0 accelerating up the ramp for student A, and second situation is accelerating up the ramp for student B, and the third situation, that is last situation, is 0 acceleration down the ramp for student C. The toy car that we use has the smoothest wheel to create a minimal friction between the object and the ramp. For overall, the experiment succeeded in finding the total force to push the object by relation present in the situation of 0 acceleration up the inclined plane, acceleration up inclined plane, and 0 acceleration down inclined plane with a constant mass that we assume. So we can conclude that the formula of Newton's second law, F equal to ma, prove that the presence of acceleration with constant mass will require force. Thank you.